All right, so here we are. So let's go and find the velocity when the acceleration is 0. So this here is telling me the time I need to find the velocity at. So here I'm given the position function, so let's remind ourselves. So s of t is the position. If I take one derivative, that gives me the velocity. If I take two derivatives of the position or one derivative of the velocity, that gives me acceleration. So you need to know this relationship. So that's the position. So if I take one derivative, that gives me the velocity, right? So let's go do it. So 4t cubed minus 4. So they want me to find the velocity when the acceleration is 0. So I need to go right to the acceleration. So let's go take another derivative. So v prime, you don't have to write all these. I'm just making sure that you know how to find these, right? So I get 12t squared. So this will equal 0, right? The velocity acceleration is 0 at t equals 0. Now I can find the velocity. So the velocity at time 0 will be 4, 0 minus 4, so give me negative 4. All right, so this one is different. So find the acceleration when the velocity is 0. And I'm giving you the same equation here. So my s of t is t to the 4th minus 4t. My velocity is one derivative, 4t cubed minus 4. And then my acceleration is one more derivative, right? 12t squared. Okay, so when, so this is going to tell me where the time is. So set the velocity equal to 0. So v of t equals 0 gives me 4t cubed minus 4 is 0. So that gives me t cubed is 1, or t equal 1. So now I'm going to find the acceleration at that time. So a of 1 gives me 12. And I haven't given you units, so you just kind of go with what you've got. That's okay. All right. Oh, this one looks a little bit challenging. So I've got a and b here. A and b. So I want to find out what those a's and b's are, what these constants are, and where the tangent line at this point is this. Okay, so this is telling me x is equal to 1, right? And y is equal to 1. And if the tangent line has this equation, think about it, isn't 3 the slope of the tangent line? The slope of the tangent line at x equal 1. So what that means is 3 is equal to f prime of 1. 3 is the slope is equal to the derivative at x equal 1. So let's go find the derivative. Finding the derivative, I'll get 2ax plus b. Remember, a and b are just numbers, are constants. So if I want to find, so there's f, let me write it down here, f prime of x is 2ax plus b. So take the time to put in 1, 2a plus b. So there it is. So 3 is equal to 2a plus b. Oh no, I have two unknowns in one equation. I really want another equation. What else do I have here? So I use the slope, so that's one of my equations. Use the slope to find that. How about if I use the point? So what do I know about the point 1, 1? Don't I know the point 1, 1 is on this function? I do. So if I take this y equal ax squared plus bx and put x equal 1 and y equal 1 in, I get 1 is equal to a plus b. So there's my second equation. So I'm just going to write them on top of each other. 1 is equal to a plus b, 3 is 2a plus b, and you could go substitute. What I'm going to do is I've got them stacked on top of each other. I'm just going to subtract this one. So the b's will go away, right? So I have 1 minus 3 gives me negative 2. A minus 2a, that gives me a negative a, and the b's are gone. So a is equal to 2. So I can put the a equaling 2 into 1 is equal to A plus B, so that gives me B is equal to -1. So there they are, my two numbers, A and B.